Hi, in the last video, I discussed about the sign test, the first parametric test that is used for one sample t-test, equivalent to one sample t-test, or two sample paired t-test. So it is similar to that, not exactly the same, but similar to that, because one sample t-test or pair sample t-test test the hypothesis for one sample or the pair sample where the mean is equal to a certain number, or in the two sample case the mean of the two samples are equal. But in the Mann-Whitney U test, or in the sign test, you do the median test. It's kind of medians are equal, median is equal to a certain number, or the median in the two samples are equal to each other or not. But how about if the samples are independent? Okay, if two samples are independent, then what kind of test do we use? This is what we will be using. Okay, we call Mann-Whitney U test. Mann-Whitney U test is a non-parametric test used to compare two unpaired groups. Unpaired means independent samples, right? The Mann-Whitney test is based on comparison of every observation xi in the first sample with every observation yj in the second sample. Okay, the total number of pairwise comparisons that can be made is nx times ny, because we will be comparing each sample value to each sample value of the other sample. We count the number of times xi from sample 1 is greater than yj from sample 2. This number is denoted by u sub x. Similarly, the number of times an x sub I from sample 1 is smaller than yj from sample 2 is denoted by y sub y. Under the null hypothesis, we would expect u sub x and u sub y to be approximately equal. So meaning that, so how many times the value from sample 1 are bigger than the values from sample 2, and similarly the other way, value from sample 2 are bigger than the value from sample 1. So our null hypothesis will be those two values, those two number of times the one is bigger than the other is equal to the other one. Okay, so and alternative will be not equal, and so on. So to perform the Mann-Whitney U test, we rank all the data regardless of the group. So we mix the two data set together and then you rank. Okay, and then find the sum of the rank in the first group and the sum of the rank in the second group. We use the table specific to Mann-Whitney to find out the critical values. Okay, the table for different values of alpha can be found on this website. Okay, that website has all the critical values for different sample size of the two groups, and then for different alpha values. Okay, so this Mann-Whitney U test for unpaired groups is equivalent to Wilcoxon rank sum test. Okay, so because Wilcoxon rank sum test is also used for unpaired comparing unpaired samples, and this Mann-Whitney U test is also used for unpaired samples, to compare the unpaired samples. Okay, these are the steps. I will show you each step in the example. Okay, write h sub 0 and h sub 1. That's the first step. Number 2 is rank all the data regardless of group. You mix the two samples in one group and then rank all the data. In case of the tied ranks, assign the average rank. So you know what that means, right? If two numbers are equal, they will be getting the same rank, right? So in that case, you average the ranks. You find out the average of those two ranks and you assign those repeated numbers with those tied rank value, that average value. Find the sum of the ranks in the first group and the second group. We denote by R1 and R2. The sum of the rank in the first sample is R1, sum of the rank in the second sample is R2, and calculate U1 by N1 times N2 plus N1 times N1 plus 1 over 2 minus R1. That means sample size of first sample times sample size of second sample, and this, and then minus R1 is the sum of the ranks in the first sample. Similarly, you can find out U2 that way, where N1 and N2 are the number of data points in the two groups. Also, calculate U2 using U2 N1 N2 minus U1. What is that doing is, see, either use that formula. If you are using this formula for U1, use this formula for U2, or you can do this formula for U2 and then this formula for U1. So either do that or do that one, okay, to find out U1 and U2. Okay, choose the larger of U1 and U2 and denote by U. So from this or this and this or this and this, pick the bigger value of that and denote by U. So U is the test value. So with the given alpha, N1 and N2, find the critical values using the table. In the next slide, you will see that table. And note that there is another type of table, so don't get confused with another type of table, which rejects when that is less than the critical value. So if the test value is U is greater or equals to the critical value, if test value is bigger than the critical value, then reject the null hypothesis, otherwise do not reject. Okay, let's see an example, then things will be clear for you guys. Okay, let me do that. I will go side by side in the R and on this one. Okay, so this is slide number 12. This one is slide number 12. I think it should be slide 12 here. Okay, all right, so let us look at this. So what do you see here on this example is the sagebrush cricket has an unusual form of mating. During mating, the male offers his fleshy hind wings to the female to eat. The wounds are not fatal, but a male with already nibbled wings is less likely to be chosen by females he meets later. Females get some nutrition from feeding on the wings, which raises the question, are females more likely to mate if they are hungry? Johnson et al. Divide 24 females into two groups, one group with 11 females and the other with 13, right? So 11 females starved for 2 days, at least 2 days, and another group of 13 was fed during the same period. So then each female was put separately into a cage with single male, and the recording of the waiting time to mating is given below. That's the experiment they did, right? So starved, these are the mating time, the waiting time for the mating, and the fed, these are the waiting time for the mating. So for alpha equals to 0.05, test the claim that the time for mating differs between the two groups. Okay, so we want to use the Mann-whitney U test, because you see that there are two different samples and these two groups are independent to each other. Okay, these two samples are independent to each other, so we are using the Mann-whitney U test. We cannot use sign test because sign test is used for the paired sample or one sample. Okay, now what is the H sub 0 is the time to mating is the same for female crickets that were starved and that were fed, and time are different. Okay, that is the H0 and H1. So now, so we need to find out U1 and U2. To find out U1 and U2, you need to find R1. What is the R1? R1 is the sum of the ranks in the first sample, but to find out R1, we need to rank all those. We need to mix these two samples together and then rank them, and then add the rank in the first group and add the rank in the second group. Look at this. So this is A, starved one. Okay, this is B, that is the fed one. Now what I'm doing here on line 43 is C equals to, I'm giving the name C, CAB, meaning it will combine this with that one. Okay, let us see that, how that looks like. Look at that. You see that? A and B are combined, but the order is not changed at all. See, on A there is 1.9, 2.1, 3.8 and so on. And on B it starts from 1.5, where? Here. So these are the elements from B and these are the elements from C. Now what I'm going is, on this group, on this single group, I'm ranking it. How? D equals to rank of C. Let's look at that, and then that is the rank. That is the rank for all of those. So what we know here is the first one has 11. So the first 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So these are the ranks from the first group. And the remaining, these are the ranks from the second group. Okay, so what is R1? R1 is the sum of the ranks from the first group. So you add these. How? Look at that R1. R1 is sum of the D's from 1 through 11. Look at the bracket and parenthesis combination here. Be careful when you do that. So that is the value of R1. Okay, let me find out what is R1 there. R1 is basically 121. You see that? R1 is 121 there, because these are the ranks from this sample 1. If you add all these numbers, you will get 121. So how do I find out U1 now then? So U1 is what is the formula for U1? Formula for U1 is N1 times N2. N1 is what? Length of sample size of A, and sample size of B is N2. And N1 times N1 plus 1, I am doing exactly the same thing. Look at this. Length of A times length of B is N1 times N2 plus length of A times length of A plus 1 divided by 2 minus R1. That's what I am doing. That is, I denoted by U1. U1 is 88. Did you see U1 is 88 there? That is 88. Now, what is U2? Whenever you are using U1 is as this formula, then you need to use U2 as this formula. N1 times N2 minus U1. Look at this. N1 is length of A times N2 is length of B, means how many data points are there, minus U1. That is U2. So U2 is 55. So U is the maximum of U1 and U2. You see that? Choose larger of U1 and U2 and denote by U. That is, maximum of U1 and U2 is U. So U is 88. Now look at this. So here we got U equals to 88. You see that? Now, to find out the critical value, we use the table. Alpha is 0.05, 2 tail, N1 is 11, N2 is 13. Look at that. N1 is 11, this one, N2 is 13. That is N1, N2, right? And 2 tail is L2. You look at that L2 thing. And 0.05, what is that? This one. So go down there. I got 106. See, 13 N2, N1 is 11, and then 2 tail, and then 0.05 is 106. Look at this. That critical value is 106. What is our U value? Is 88. Critical value is 106. Since the U is less than the critical value, we do not reject. If U is bigger, we reject. Since U is less than the critical value, then we do not reject. So what will be the conclusion then? We do not reject means the conclusion will be the time to mating is same for female crickets that were starved versus that were feed. That's what we are able to conclude from here. Okay, guys. So I will post the homework problem there. But let us see that instead of doing all these long steps, there is a straightforward formula in R. Do directly from R. Wilcox.test. That's what we use. Because do you remember that I was mentioning that the Mann-Whitney U test for unpaired group is same as the Wilcoxon rank sum test. That's what it does. Wilcox.test. And then A is the first sample, B is the second sample, paired is false. It is not paired one. Confidence interval is 0.95 because alpha is not given meaning. You take 0.05, okay. And then exact equals to false. We keep that exact equals to false. And look at this. What do we get? So when you do that, I got P value is greater than alpha. Because P is greater than alpha. P is 0.35, which is greater than 0.05, okay. So we do not reject the null hypothesis, meaning we are just basically supporting that. So the time of mating is same for both type of crickets. So that's how we do the Mann-Whitney U test, which is a non-parametric test to compare two samples, basically. Okay, and then I showed both ways, just direct method and you do by manually using R. Okay, guys, thank you.